Here's problem number 19. We're going to try to find the values of x that keep us below a particular error range. We're going to remember that the error is the absolute value of the remainder and can be found by taking the maximum value that the derivative takes on in the next term, minus a to the n plus 1 power all over n plus 1 factorial. Now in this case, the Taylor polynomial, which estimates sine, I can see that the largest power here is 3, but I also know that the next term here is 0 times x to the 4th. I declare this to be the fourth order Taylor polynomial, and therefore the error, as given by the Taylor remainder theorem, is going to be the maximum value that the fifth derivative takes on times x to the 5th, as the center is 0, over 5 factorial. And the maximum value that the fifth derivative takes on, since it's either sine, cosine, negative sine, or negative cosine, is the value 1. And now I want to know, well, when is that value? Sorry, I messed up here. This is an equal. These remainders have to be less than this value. And we want to know, when is this less than 5 times 10 to the negative 4th? So if we solve this algebraically, we get x to the 5th is less than or equal to 5 factorial times 5 times 10 to the negative 4th, and then we're going to take the 5th root of that. When is that true? Well, on the calculator, we can find that out. On the calculator, we can find out what's the 5th root of 5 factorial times 5 times 10 to the negative 4th, and we'll take this to the power of 0.2, which is 1/5, and so there we have it. Now that tells us where the error, the remainder, and the least, or the highest acceptable error is. And just want to recall that the Taylor polynomial estimator is going to be most accurate nearest the center. So we're talking from 0 to essentially 5.67 in either direction is going to work out there. Let's see if we can take a look at this graphically. Let me add a graphing window. And in that window, I am going to write essentially what we're trying to find, which is I want to find the absolute value of sine of x minus my estimator of sine of x, which was x minus x cubed divided by 6. So there's my error, and we can see that the error is closest to 0 when x is close to 0, and the further we get away from 0, the larger the error becomes. Well, let's find out where this graphically crosses my minimum acceptable error. 5 times 10 to the negative 4th. Now, hard to see where that intersection is, so let's zoom in. Let's change the window to see if we can get in there. I'm going to change the window settings. I'm going to ask, well, how about we go from negative 1 to 1. Back up there, get that negative 1 in there. And then let's let's go from x min from 0, and let's go twice as big as 5 times 10 to the negative 4th. Let's go 10 times 10 to the negative 4th. That's twice as big as 5 times 10 to the negative 4th. Oh, I'm sorry, I lost my negative sign way up there. Let me get that in there. Enter. 0. Oh, sorry. I lost my caret here. Let's get that caret in there. There we go. And so here we have it. The blue line is below the red line when we're near 0 and going out to some value. I wonder what that value is. Let's look for the intersection. So let's analyze the graph for the intersection. My lower bound to my upper, whoops, didn't mean to grab there. My lower bound to my upper bound. And we can see indeed we're seeing like a value that's around 5.71. So there we have it, the error calculated by hand using the theorem and the error calculated graphically.